Probability. So we'll be looking at dependent and independent events. Two events, if the occurrence or non-occurrence of A does not affect the occurrence or non-occurrence of B. So therefore, A and B are independent events if probability of A intersection B is equal to probability of A multiplied by probability of B. Otherwise, they are dependent. Now, to stress more on it, let's assume that we consider a random experiment in which two balls are picked randomly from a basket which contains three white balls and five blue balls without replacement. Now, the event 2 is said to be dependent on the event 1. But if picking, however, is done with replacement, then event 1 and 2 will be what? Dependent of each other. Is that clear? Now, in general now, if A1, A2, A3 up to AN are n independent events, then probability of occurrence of A1, A2 up to AN is given as probability of A1 multiplied by probability of A2 up to probability of AN. That is, probability of A1 intersection A2 up to intersection AN is equal to probability of A1 multiplied by probability of A2 multiplied by probability of up to AN. Now, after this, let's look at conditional probability. So let A be an arbitrary event in a sample S with probability of A greater than 0. The probability that an event B occurs once A has occurred, or in other words, the conditional probability of B given A is, that is, probability of B take away what? A is equal to probability of A intersection B divided by probability of A. So this one is more or less a dependent probability. Is that clear? That is the probability that event B occurs once A has occurred. Event B occurred once A has what? Has occurred is equal to probability of A intersection B divided by probability of A. Now, suppose S is a finite probable space with events A and B, then probability of B take away A is equal to number of ways A and B can occur divided by number of ways A can occur. Now, let's look at some examples. Example 1. Here, the probability that Ojo will attend Musa's birthday party is 0.6, and the probability that Chuku attending the same party is 0.4. What is the probability that both of them will attend the party? Now, solution. Let A be an event that Ojo is attending the party, and B be an event that Chuku is attending too. Thus, A and B are independent events. Yes, A and B are what? They are independent events because Ojo and Chuku, they are not living together, so they are not together, so they are independent. Now, probability that both of them attending the party is equal to probability of A intersection B, which is equal to probability of A multiplied by probability of B. So probability of A is 0.6 multiplied by probability of B is equal to 0.4. So 0.6 multiplied by 0.4 is equal to what? Probability is equal to 20 is 0.24. So which is the probability that both of them attending the party. Now let's look at another example. Example 2. Bus A contains 10 balls of which 6 are red, and bus B contains 6 balls of which 2 are red. Now this one now, 10 balls of which 6 are red. This one 6 balls of which 2 are red. Now a ball is drawn at random from each bus. From what? From each bus. Don't forget we have 2 buses now, A and bus B, right? Now a ball is drawn at random from, so what is the probability that both are not red balls? You can see that this one is also independent. A is independent of what? Of B. So the probability of choosing a ball which is not red in bus A, the total balls here, they are what? 10. So out of which 6 are red, so the number that are not red will be 10 minus 6, which is equal to what? 4 over 10, which is equal to, divide this one by 2, divide this one by 2, you get 2 over 5. Also, the probability of choosing a ball which is not read in box B. Which is not read in box B. You know, in box B, we have 6 balls, out of which 2 are red. So 6 minus 2 is equal to 4. So we have 4 over 6 that are not red. So divided by 2, we have 2 over 3. Now, since speaking of ball in box A and box B are independent, then the required probability is equal to probability of not read in A, then probability of not read in B, which is equal to 2 over 5 multiplied by 2 over 3, which is equal to 4 over 15. Is that clear? Now, the third example will now be on conditional probability. In a certain secondary school, 30% of the students failed mathematics, 15% of the students failed physics, and 5% of the students failed both mathematics and physics. A student is selected at random. What is the probability that he failed physics? The probability that he failed physics. Now, solution. Let M be the students who failed mathematics and Y be the students who failed physics. Then, probability of students who fail mathematics will be 30. You know, it's 30%. 30 divided by 100 will give you 0.3. Then probability, the students who failed physics is equal to 0.15. That is 15%. 15 divided by 100 will give you a 0.15. Then 5% failed both mathematics and physics. So it will be 5 divided by 100, 0.05. So the probability that a student failed physics, given that he has failed mathematics, no, because he has what? He has failed mathematics. The reason why it is pertinent to use this formula now is we don't know the total number of students in this school. Is that okay? We don't know the total number of students, but we know the percentage of the students who failed both mathematics and physics. So we can use this one now. The probability that a student failed physics, given that he has failed mathematics, is equal to probability of y take away what? Mathematics is equal to probability of y intersection m, which is divided by probability of mathematics. Is that okay? Because he has failed mathematics before, right? So probability of this intersection is equal to 0.05, which is equal to this, divided by probability of failing mathematics is equal to 0.3. So 0.05 divided by 0.3. So if you simplify this, you are going to get 1 over 6. So, and that is that about independent. So if this one is clear now, I would like you to do this one for me. Let A and B be events with P probability equal to 1 over 2, probability of B is equal to 1 over 3, then probability of intersection B is equal to 4. Now find probability of A take away B, probability of A complement take away B complements, then probability of A union B.